Welcome back. Now, before we can start actually using KVM, we need to step back and talk a little about what virtualization itself is. So, simply put, virtualization is really taking something that is actual and virtualizing it. There's different types of virtualization, such as hardware virtualization, partial virtualization, and para-virtualization. With full virtualization, of course, in the technology world, is what we're going to talk about in virtualization, is basically where, with full virtualization, we use hardware capabilities of the processor to allow guests, or guest operating systems, to use the features of the host physical system. In other words, what we're doing is creating a new virtual system called a virtual machine. This allows us to have a guest operating system to run without any modifications whatsoever. The guest operating system and any of the applications on this guest virtual machine are actually unaware of their virtualized environment, if you will, and they run as if they were on their own physical machine. The KVM, or kernel-based virtual machine hypervisor in Red Hat Enterprise Linux, uses full virtualization. This is provided by the hardware-assisted virtualization method. Now, with para-virtualization, this employs a collection of software and data structures that are presented to the virtualized guest. In other words, this requires software modifications to the guest, and they use a para-virtualized environment. Para-virtualization can encompass the entire kernel, as in the case for Zen, para-virtualized guests or drivers that virtualize I/O devices. We'll discuss more about what the Linux kernel and user space is later on, as well as I/O devices. But really, in a nutshell, para-virtualization means that you're providing interfaces more optimally than real hardware. The advantage of para-virtualization is that it's faster than full virtualization, but the disadvantage of para-virtualization versus full virtualization is that the guest operating system is actually going to require special device drivers. Another form of virtualization is desktop virtualization. An example of this is virtual desktop infrastructure, or VDI. VDI can be thought of as a more advanced form of hardware virtualization. Rather than interacting with the host computer directly via a keyboard, mouse, and monitor, the user instead interacts with the host computer using another desktop computer or even a mobile device by means of the network connection, such as a LAN, wireless LAN, or even the internet itself. In addition, the host computer in this scenario becomes the server computer capable of hosting multiple virtual machines at the same time for multiple users. Now, as the name suggests, the VMM or hypervisor is a piece of software that is responsible for monitoring and controlling virtual machines or guest operating systems. The hypervisor is responsible for ensuring different virtualization management tasks, such as providing virtual hardware, virtual machine lifecycle management, the migrating of those virtual machines from host to host, allocating resources in real time, and defining policies for virtual machine management, and so on. Now, the hypervisor is also responsible for efficiently controlling physical platform resources, such as the memory, translation, and I/O mapping. One of the main advantages of virtualization software is the capability to run multiple guest operating systems on the same physical system or hardware. The multiple guest systems can then be using the same operating system or even different ones. For example, there could be multiple Linux guest systems running on top of the same physical system. The hypervisor is responsible to allocate the resources requested by these guest operating systems. The system hardware, such as the processor, memory, and so on, has to be allocated to these guest virtual operating systems according to their configuration, and the hypervisor can take care of that task for us. Because of this, the hypervisor is a very critical component of any virtualization environment. Depending on the location of your hypervisor and where it's placed, it's usually categorized at either a Type 1 or Type 2 hypervisor. Type 1 or Type 2 hypervisors are based again on where they reside within the system, or in other terms, whether the underlying operating system is present in the system or there's not an underlying operating system. If the hypervisor is running directly on top of our hardware, it's generally considered to be a Type 1 hypervisor. However, if there's an operating system present, then the hypervisor operates at a separate layer. It's going to be considered a Type 2 hypervisor. So for example, this is a Type 1 hypervisor.